Mix it with my mixing chip. Deeper look at attack and release times of a compressor. I recently got an email question from a client. It was about attack and release times, student actually of the school. And what they were asking about was how the exact order of things go in terms of the attack release. The one thing that the easiest way to kind of start to talk about attack and release times and working with audio is to sort of think about it through the ADSR cycle. And I sort of screwed that up. ADSR, so attack, decay, sustain, release. And in the attack, decay, sustain, release cycle, you have compression that can work on any or all of the above components of the sound, and that's kind of the idea of working with compression. Is it gives you some, although limited, control over sounds. In the creation of original sounds, whether they're acoustic sounds where you have the least amount of control or synthetically generated sounds where you have control over elements of attack, decay, sustain, release, the compression offers a way of kind of giving you some measure of control around that. So what the question was centered around is when you set the attack time to a specific value, and let's say you set it to 5 milliseconds, does that mean that the attack is delayed by 5 milliseconds? And the answer to that technically is no. Now, it depends on what and how you kind of, where you start from. It's not like a simple straight ahead answer, because when you think about compression and where it evolved from, it really evolved from the broadcast industry. And the broadcast industry tried as hard as it can to make the attack time of its broadcast limiters instantaneously. And there were difficulties in doing that. Technical issues. Some would even delay the actual broadcast signal so that the original signal could pre-trigger the audio, and the compression would key in before the actual audio that transmitted played, and this would give them the ability to sort of time it out. And that was kind of one of the only technical ways of doing it. See, the issue when you actually, if you go to vintage gear and vintage emulations, you have sort of one formula, and then when you go to plugins that are created just purely digital, you basically anything goes. And that's what makes the sort of attack and release time. So the full question was, if the attack, does that delay? And the answer is no. And the release, where does that begin? Does that begin after the 5 millisecond attack? And that is also a no. So if the release time was 100 milliseconds, you would say, oh, okay, well then 105 milliseconds later, the signal would be back to normal level, and that's not actually the case. And what happens when the signal passes through the threshold is it have to go back through the threshold in order for the attack time to become the release part of the cycle, and how long does that take? And so you get into all these crazy things. So what is sort of come from the vintage realm, and it's sort of like a way of averaging out things. The problem with going through analog components is that all analog components exhibit some compression or gain loss characteristics naturally, and that will depend on how much signal is pushed through them. So when a component or a compressor is designed, the components that are used are specifically optimized for the voltages that are optimal operating ranges, line level signals, and that's where you're getting the optimum use of those components. But when you start to overdrive or push more level in, then you start to get distortions that were not part of the original design. And those distortions can be nonlinear. They're not exactly linear. And so as a result, if you actually start feeding a signal into a tube limiter, and you may get some form of gain reduction through the processing before you even apply any gain reduction, because as it passes through transformers and the tube components, there already is going to be a limiting of those high peak signals that saturate the tube for instantaneous sections. And also, it's not a linear thing. In terms of like setting a ratio, with analog components, especially when you get to things like tube limiters or tape saturation or optical components, what ends up happening is that the ratio is sort of an average of sort of a medium line that's decided, and that's why it's hard sometimes to find exacting ratios on some of vintage like tube limiters and things like that, or even if you look up specifications for things on, an LA2A or something like that, an optical limiter, you don't get necessarily exact number. So they'll quote a number, but it's not really a true full number. In other words, it's not always 20 to 1, or it's not always 5 to 1, because it depends how much you drive the circuit. And this is what starts to complicate matters and also kind of makes it more musical sounding. It's sort of a difference. What happened in the early digital era, when early digital compressors were put in, is they sounded weird. It was a sound that was mathematically correct and had nothing to do with what any engineer had ever heard before, because they were using analog components that were feeding in compression characteristics that they didn't necessarily understand. I don't know that I really remember specific numbers if they weren't written on the actual knob in some way, or a switched stepped position where I could look at it. I didn't think of it numerically. It was a variable pot. I would just control it until it sounded right, and then maybe look at the number later. It wasn't until digital that I started to kind of take note of those things. And so what happened is a lot of the analog characteristics were sort of moved back into the creation of plugins and things like that. So let me explain a little bit about just what the attack time is. On many compressors, what happened is you have a sort of natural knee that is built in. So in other words, in a weird way, what happens is there's two ways to look at it. You could say that the ratio is sort of ramped up, or you could say that the compression, and that is a matter of the saturation capabilities of the circuit. So, for example, if you're working at an 1176, for example, and you select a 4-to-1 ratio, essentially the threshold might be down here for a 4-to-1 ratio. And then if you select 8-to-1, the threshold actually shifts up to a higher place. And so as you go up the scale, you go up 20-to-1, and that threshold is at a higher place. So the idea then becomes, when you actually switch between the different ratio values, what you end up getting is you don't get that extra amount of gain reduction that you would necessarily expect. So if you had 10 dB above threshold, and it was a 4-to-1 ratio, let's say it was a 2-to-1 ratio to make the math easy, it would be 5 dB a gain reduction. If it was 4-to-1, then it would be half that, or double that. So you start to get into things where the amount of gain reduction doesn't seem to kind of match up when you look at it on 1176. And the way that they do that, and the SSL compressor, bus compressor, is done in a very similar way, is that they just shift the threshold on the course of the knee that ramps up the gain reduction. So when you switch between those different ratios, you get a different characteristic, but you don't necessarily get an extreme change in the gain reduction, and that makes it actually a more usable thing. So technically, when you set a threshold at a specific amount, it should stay at that specific amount, and that's more what happens in a plugin situation. So then this becomes sort of difficult to explain. What ends up happening, there is a mathematical formula, a way of calculating what the attack time is. So if you, for example, had a 5 millisecond attack time, that is the 3/4 point to peak gain reduction. So in other words, the attack, if this is the course of 5 milliseconds, so this is 0, we're going through the course of time, this is 5 milliseconds, let's just say this is 10 milliseconds here, then this would be the sort of 3/4 point of the total amount of gain reduction. And then it would go like another quarter up to there. So now you've got this point where they're sort of taking and they're saying, oh, okay, this is the attack time. It occurs over 5 milliseconds, but it doesn't come to full peak reduction until another quarter of time later on top of that. So if that doesn't dizzy your head, then what happens is, once you've reached peak gain reduction and the gain reduction starts to go down, that's the beginning of the release cycle, technically. So it complicates things. It makes things a lot more difficult to understand. And in a way, it like the best analogy to this is kind of what happens with mathematics and physics. In theory, if you roll a ball down a road, it'll just kind of go at the same speed, at the same rate, straight line forever and ever and ever. But of course, it meets resistance along the way. So then then the way to get around that is you get into quantum physics, where you talk about probabilities, and you say, what's the probability that it's going to go left, that it's going to go right? How far is it going to go? Based on all of this and what we can calculate on this. And every time you rolled that ball down the street, it would be slightly different. There would be some microscopically small change in there that would shift it one direction or the other direction, or slow it down a little bit more than the previous time, make it bounce a little bit, some other crazy thing. And this is sort of what happens in the realm of working with analog components. Now, when you get to the digital realm, what you see on a lot of compressors is the ability to add the modeling characteristics, especially the release characteristics, which are unique with different analog components, into it. So you'll see like a tube or a tape or an optical setting. And what happens is that the release, while technically you think of it as a linear decay, the gain reduction going back to non-gain reduced signal, then, or the gain reduction, as it's occurring, goes back to original no gain reduction, right? However you want to map it out, whether you want to go up or down. I'm just doing it down because thinking of the needle kind of going down in terms of the gain reduction meter to zero gain reduction. Then depending upon the component that you use, if you use an optical component, it may have like a slow initial and a fast total release at the end. And if you use some other solid state kind of component, it may actually have an initial quicker release and a more gradual move towards the end. And so now you get a little bit more closer to S-shaped type of characteristics or curved characteristics as opposed to linear characteristics. And those things actually really shape the character of the release. The release and the attack are probably the most powerful elements of any compression, especially when you get to digital compression, because you have control that doesn't exist typically in most other, in analog components. It's hard to get that except for on, some FET compressors and VCA compressors where, they can be more accurately calibrated to more accurate millisecond settings and things like that. But when they're going through more physical component driven gain reduction, where it's a matter of overdriving a particular thing like a tube or an optical circuit or something like that, the characteristics start to become unique in that way. The ratio really on analog components is more of a variable kind of thing, and that sort of relates a bit to the knee characteristic and the way that kind of plays in. So there's all of these relationships between the thing, and it's sort of like a big fuzzy mess in a way, and not as easy to understand and mathematically pure as you'd like it to be. The key thing is that, and one of the things is that you're never going to read any kind of a manual, and you don't generally see technical specifications on plugins because no company wants to quote unquote release their secrets or whatever that is, whatever their formula is. They mostly do things by ear. They create an attack time, and the attack time may be a delay, or it may offset the amount of time before the threshold trigger is enabled, meaning that if a transient pops through and then 5 milliseconds later is on its way down, is already passed through, that point in the level may not actually have exceeded the threshold, and so very little gain reduction ends up getting applied. Or depending upon how much signal is above that threshold, you get into all kind of crazy things with the plugin design that are all unique. I guess the bottom line of all of this is to probably confuse matters more than anything, but really more or less to talk about how, in essence, what really occurs in plugins is kind of unknown. At least with analog components, believe it or not, there are technical specifications, there are schematic drawings that are available, and there are people who can dissect and pull these things out and measure those characteristics. And once those characteristics are measured, they can be modeled. And that's going to be another mixing tip, which I'm going to talk about, is like modeling characteristics and essentially how that works and what works well about it and what doesn't work well about it. But when you get into all of that math, ultimately you just have to use your ear and gauge the usability of a particular plugin, and how well that it works in the digital realm, and not get too caught up in the numbers. I do a lot of release time stuff that's tempo related, which is very cool way of working with release times that helps them to have a musical value. I like compressors like the Renaissance compressor because it has shaping in it for electro, what they call electro, and opto, which are different, like optical and like a solid state type of characteristic. And what ends up happening is that it adds a shape or character which is musical one way or the other. So I can select that, and it helps the release time to have the character shape that I want it to. So if you work on a plugin, the Pro C2 is another excellent one that has some of those characteristics as well. And shaping that release characteristic and working with musical timings is something that's like a really, really cool way to make a compressor do what it is that you want it to do. So those are the things, and you notice a lot of them also have knee controls, where this is never really a variable control on most components, analog components that you've seen. I think there was a sort of non-front adjustment on a Fairchild that had something to do with the knee characteristic. You can see that on the Universal Audio emulation, where there's actually a control on a tweaker pot that probably everyone was instructed not to touch under any circumstances once it was set to the chief engineer's liking. All right, so anyway, that's a little thing just to confuse matters a little bit. A little bit of discussion, and hopefully trying at least a kind of attempt for whatever it is to take a deeper look at what attack and release times and why that is so confusing, what the characteristics are.